I've got problems 2 and 3 up on the board here. 2 is just filling in the blank to summarize what we noticed with the last couple of examples. So they say if h is a positive number, so I'm telling you it's positive, g of x is f of x plus h. Notice that has us adding h and then plugging that into f. Then the graph of g of x will be like the graph of f of x shifted. You tell me what direction, we're going to shift it by h units. And then part B, same thing. H is again a positive number, but this time we're going to subtract it before we plug into f. You tell me what direction that's going to shift things. And then problem 3, I'm giving you the graph of a function f of x here. On the worksheet, there are grid lines drawn in. I will just tell you that these points all have integer coefficients. Okay, so they do appear. It's actually not drawn very nicely. Let's fix that. There we go. That's a little better. If you have the worksheet, you can see they're on the grid. Those points are on the grid lines. I'm telling you that g of x is f of x plus 2 minus 3. So we're doing two things. We're adding 2 before we plug into f, and then we're subtracting 3. See if you can figure out what the graph of that looks like. Go ahead and pause the video now. Try to work those two problems out. Then tune back in and we'll check your answers. I've got the answers to problem 2 up here. If we add a number before we plug into a function, it shifts the graph to the left. And if we subtract a number before we plug into a function, again, we're changing the input, so that's going to change things horizontally, and it shifts things to the right. So I just need to remember that horizontal transformations are a little bit counterintuitive, and we saw why that was the case. It's because if we're changing the input, we have to solve for what x needs to be in order to give us the inputs that give us the familiar y values that we're trying to get. All right, I haven't done problem 3 yet. I thought we'd work through that together. I could just put the answer up, and I'm guessing that a lot of you were able to figure that out and get the correct thing. I'm just going to introduce you to a method of bookkeeping for keeping track of things, because as we work through this chapter, we're going to be learning more and more transformations, and I find it helpful to be systematic about how I go about things. So if I look at this, I'm going to create a table where I'm going to just write down what I would do if I were evaluating the function at a particular number. So for example, if I was going to plug in 3, what's the first thing I would do? And then I'm going to record how that affects the graph. So I'm going to write down the corresponding transformation that I get for the graph. So if I were plugging in a number, let's just say I did want to plug in 3. Well, I can see there's where 3 is. The first thing I would do is I would add 2. Once I've done that, now I've got a 5 here, then I would plug into f. So that's going to be my parent function. That's going to give me the known graph that I have. And once I've done that, I would subtract 3. Okay. Now, what's kind of nice about this is I can see, here's where the parent function is. Anything I did before I plugged into the parent function, that was changing the input. If I change the input to my function, that's going to be a horizontal change. Anything I do after I've plugged into f, that's changing the output. That's changing my y values, so that's going to give me a vertical change. And then I can say, okay, if it was horizontal and I added 2, I know that's going to shift me to the left 2. Remembering that horizontal transformations are a little bit counterintuitive, adding 2 moves things in the negative direction. Then for the vertical transformation, we were subtracting 3. That's going to move everything down 3. So I can see what I'm going to do is I'm going to go left 2 and down 3. Now, you may very well be comfortable doing that all in one step, and I'm fine if you do. I'm going to go ahead and do it in 2 separate steps, just because this is relatively new, and I find it's easier to keep track of things if I don't try to multitask. Now, when I have just some horizontal and some vertical transformations, it does not matter which I do first. I'm going to just go in this order. I'm going to do the horizontal first and then the vertical because that's the order in which I've written them down. But it doesn't matter because going left 2 and down 3 is going to take me to exactly the same place as if I went down 3 and then left 2. So their order doesn't matter. We will see in a little bit that if I have multiple vertical or multiple horizontal transformations, the order in which I perform them will matter. But if I've got some of each, it doesn't matter whether I do the horizontal or the vertical stuff first. Now, with this function, I can see there are 3 important points. I'm just going to label their coordinates. So this would be -2, -1. This is going to be the point 0, 3. And this is the point 2, 1. So now I'm just going to move everything to the left 2. Now what that's going to do is I'm going to, for all of these points, the y value stays the same, and I'm going to do the opposite of this. I'm going to subtract 2 from each of the x values. So this point is going to move to -4, -1. Same y value, but I've changed the x value. This point is going to move to -2, 3. And this point will move to 0, 1. But it's the same basic shape, sort of an upside down V-ish thing, where that's a straight line. Okay, and now I'm going to move everything down 3. So this graph will be my final graph. This was just a working graph where I'd done part of the work. Okay, so if I'm moving things down 3, I'm going to do exactly this to the y values. Keep the x value the same, but change the y value by subtracting 3. So -4, -1, I'm going to subtract 3, which will move it down 3, and I get -4, -4. -2, 3, if I subtract 3 from that y value, I'll now be at -2, 0. And 0, 1, if I subtract 3 from that y value, it's going to now be at 0, -2. Excellent. Now, when you're doing quizzes and exams, if you have graph paper, you're welcome to use it. If you don't have graph paper, that's fine. It's not required. Some people find it helpful to have the grid lines drawn in. Some people are comfortable just drawing in tick marks. It should be clear where the points are, though. So if you're not using graph paper, you should be labeling the coordinates of the points as I did here. If you are using graph paper, probably still a good idea to label those points. Let's just make that a rule. Let's label the important points. But notice, I didn't have to do this for all of the infinitely many points one at a time. I just found the 3 crucial points, starting point, ending point, and there was a turning point in the middle, plotted those, and then was able to connect the dots because I knew that the overall shape was preserved.